The next case we're going to look at with permutations is we're going to change the situation. Instead of lining everything up in a line, we're going to arrange things in a circle. How does this change what happens? Well, it's all about how the first object can be arranged. Let's look at the difference. Here's a line. Remember, we've got n objects over there in the corner. Well, let's give it numbers rather than n. So we've got 6 objects. When I have a line, there's a definite starting and finishing place. So if I put the first object in the first spot, it's different to if I put it in the last spot. Okay? So the first object has a choice of 6 positions. But when I put it in a circle does not have a definite start or finish. So it does not matter where I put that first object in the circle. There's only one place I can put it, in the circle. Once the object is in the circle, then it defines all the other positions. Because you can say, 2 to the left of it, or 3 to the right, or something like that. But when there's no objects in the circle, you can't define the positions, because you might say, yes, well, this is position number 2, and I'll go, yeah, watch this. I'll turn the circle. Still the same arrangements. So a line, back to our n objects. First one, if we're in a line, has n possibilities, but in a circle it only has one possibility. Goes in the circle. Second object, in a line would be n minus 1, but now it's also n minus 1 for the circle as well. Because we have an object now, so I can define the other n minus 1 positions, and everything else now will stay the same until we get to our last object, where there'll just be one spot for it. So basically, it's n factorial divided by n, the number of spots I could have put that first object. Well, that's just n minus 1 factorial in effect. So if we're in a circle instead of a line, it's just n minus 1 factorial. We take 1 off the total number of objects that we have. Well, let's look at some examples. We go into a meeting room. We've got 10 chairs around our table. By the way, they say round tables. They don't have to be round tables the shape of the table is irrelevant. When you can have a square table, but the chairs are still rounded, so it doesn't matter. A committee of 10 people includes 3 teenagers. How many arrangements are there in which all 3 of them sit together? Okay, so first thing we'll do is organise the 3 teenagers, so 3 factorial ways. I'm now going to arrange all of the objects, but not in a line, in a circle. So the 3 teenagers are now like one object. There's another, how many did we have all up? We had 10 people all up. So there's another 7. So 7 plus the group makes 8 objects I'm arranging, but I'm arranging them in a circle rather than in a line. So 7 factorial, not 8 factorial. We're going to elect a chairperson and a secretary of our committee. What's the probability that they're directly across from each other? Well, if there was no restrictions, we know there's 9 factorial ways that we could put people in our circle. So that would be the bottom of the fraction, total number of possibilities. Now, with restrictions, okay, El Presidente, which we've just renamed the chairperson. Okay, chairperson must be the president. There's only one spot. We're going to let them sit in the circle first. You choose where you'd like to sit, but it's in a circle, so there's no defined positions yet. So they just go sit in the circle. Now the secretary wants to go opposite the president. So there's now only one seat they can go in. It's got to be across wherever the president or chairperson chose to sit. That leaves another, how many people? 8 people to go. But it's now like a line because the positions are defined, so it's 8 factorial. 8 factorial. 1 times 1 times 8 factorial over 9 factorial, which all simplifies down to be 1 in 9. By the way, don't forget about simple logic. Could have done that question a lot quicker. President's going to sit down, right? There's 9 seats left for the secretary to sit in. What's the chance that they sit opposite the president? Oh, 1 in 9. 9 seats, there's only one of them opposite. So So you could have just done it that way. Here's one from 2002. 7 people are around the table. How many are possible? So, all right, it was 7, but we're going around a table instead of in a line. So it'll be 1 less, 6 factorial. So that's a nice little gift marked, and we say, thank you very much, I'll take that. 2 people, Kevin and Jill, refuse to sit next to each other. So how many arrangements are possible? You know, it's a lot easier to work out how many arrangements where they are together rather than working out the number of ways they are not together. So you work out the number of ways they are together, then just subtract them from the total number of possibilities. So let's work out they are together. So Kevin and Jill, they've just made up for a second, so all right, yep, they want to be together. 2 factorial of arranging Kevin and Jill. So they're now like one person. So we will now multiply it by 5 factorial. Because we've now got our group of 2 plus another 5 people gives us 6 objects, but we're placing them in a circle, not a line, so it's 5 factorial. 240. Now, if you find this idea of taking one off, you can think about it this way. As long as you remember there's always one way to place the first person in a circle. Because what I could have said was, well, 2 factorial, I've arranged the 2, now I'm going to say to those 2, go and sit in the circle. Well, there's only one way they can sit down because they're going in a circle. Now I'm going to arrange the other 5 people, 5 factorial. So you could think of it like that. So our total arrangements, we want to subtract that 240, so we have 480 possibilities, 480. There's a little flow chart of permutations and combinations, I guess the things we're looking out for. Okay, so we sort of start at the top, perms and coms, and then we go, well, hang on, is order important or not important? Well, if it's not important, we know it's a combination. If it's important, we know it's a permutation, but now we go permutations. Is it in a line or a circle? So a circle is n minus 1 factorial. But then the other things we looked at is in a line, did we use all of the items? That was just n factorial. Or did we just use some of the items? And that was npr. And when we used all of the items, we said, well, hang on, is each item identical? Oh, sorry, different, not identical. If it's identical, it'd be an easy question. Just one, put them there. Each item's unique, n factorial, or some are identical, and that's when we divide it by the number of repetitions. So that's sort of all the different cases that we've looked at. 14G, we'll just add some more questions in there. Well, that'll do us for today.